Good morning, sir. Today I am going to give a short lecture, video lecture on the topic real world applications of electric field. So, as we know that there are plenty of applications of static electric field, but in this particular video lecture, I am only constrained with these contents, right. So, first starting with Faraday's cage. Already we have done a project on how microwaves act as Faraday's cage in blocking electromagnetic radiation. So, I am not going much deeper into Faraday's cage. So, let us starting with only I am going to give an outline of Faraday's cage. Starting with Faraday's cage. Faraday's cage is nothing but a container which is made up of conducting material and it shields the electronic devices from static electric field, right. So, another application, another one important point over here I want to highlight is the airplanes are always shielded with Faraday's cage. It is because whenever the lightning strikes the airplane, if it is not shielded with Faraday's cage, there may be a possibility of damage of their interior electronics. So, airplanes are always shielded with Faraday's cage, right. So, the next we are going to see about electrostatic precipitator. Electrostatic precipitator. So, electrostatic precipitator, it is generally a device which is used in thermal power plants to remove dust particle in gas exhaust, right. So, here in first diagram we can see that the working principle of electrostatic precipitator is in first diagram we can see that there are two plates. The two electrodes are positively charged electrodes which are maintained at several thousand volts, right. The negatively charged plates are generally in the form of wire mesh, right, which is in between. So, this form of arrangement when air is passed from the right side creates the discharge of, it induces the discharge of corona, that is corona discharge takes place, that in turn releases the electron. So, the dust particle, it gives the dust particle the net negative charge. So, when the net negatively charged dust particles moves in between the positively charged two electrodes, due to the movement of charges there will be obviously there will be electric field, and due to the electric field there will be a electric force with which the dust particles are moving, right. So, the dust particles gets attracted to the positive plates and from the right we get clean air. Another term over here I want to coin is scrubber. The use of scrubber in electrostatic precipitator is, scrubber has the ability to remove the gases like sulfur dioxide through the splash or through the spray of lime water, right. So, next we are going to see about the force, the electric force between the two positive electrodes. So, whenever a charge is moving, there will be an electric field due to which there will be a electric force. That electric force with which the dust particle is it is proceeding is nothing but the electric force Fe, which is given by, generally the force is given by Q into charge. Here the Qp is nothing but particle charge into electric field, right. So, here one condition arises, that condition is nothing but there will be, due to the influence of electric field, there will be a viscous drag force that opposes the force of the gas. So, there are two types of forces. The one is electric force due to the electric field movement of that negatively charged dust particle, the other is viscous drag force. So, when this viscous drag force and this electric force, that is nothing but Coulomb's force, becomes equal to each other, the particle attains terminal velocity, and it is denoted by U suffix t, and the formula is U suffix t is equal to Q EC 3 into mu dp, where dp is nothing but diameter of the particle. So, the diagram which is shown over here represents the electrostatic precipitator, which is generally used in thermal power plants and some of the industries. So, next we are going to discuss about electrostatic efficiency of electrostatic precipitator. So, As we know that the electric field is nothing but is in scientific term it is defined as the negative potential gradient, right? Electric field is. So here the maximum electric field exists at the plates. So the maximum electric field is given by V by L, V divided by L, and the efficiency eta is given by 1 minus exponential of minus WA by Q, where W is nothing but terminal velocity, A is nothing but area, Q is nothing but airflow rate. So the next application over here is nothing but inkjet printers. So inkjet printers are nothing but the computer printing, it is nothing but the computer printing which creates the digital image, right? So the working principle of inkjet printers are, in this diagram there will be ink reservoir from which the ink is collected by the pump, and the ink flows downwards due to the surface tension, and there will be several nozzles through which the droplet, there will be a equal formation of in correct shape the droplets will be formed, and the droplets are given some charges and it moves through the deflecting plates. Whenever the charges moves, so it creates an electric field, right? So but the electric field between the deflecting plates are maintained constant, right? So the force with which the droplets, so due to the electric field there will be a force, so with that force the ink falls on the paper uniformly, right? So the working principle of inkjet printers are nothing but charging of electrode and deflection of ink on the paper by the deflection plates, right? So this is nothing but the construction of inkjet printers. It consists of gutter, nozzles, charging electrodes and charge controllers, right? So the electric field between the deflecting plates are given by, generally electric field is given by force per unit positive charge. So based on the application of inkjet printers, here is one numerical. So the next application of static electric field is nothing but electrophoresis, right? So electrophoresis is nothing but it is the separation of ions in an applied electric field through the conducting medium. It is generally separated. There will be two electrodes which will be separated by some distance by an ionic medium or some conducting medium, namely electrolytic medium, right? And some there will be two plates, basically positive plate and the negative plate, and a current will be supplied to it, right? Due to the supplied current there will be a migration and there will be accumulation of ions in that particular case, right? That is known as electrophoresis. So when the ions start migrating and accumulate, and when it starts accumulated, there will be a velocity with which the ions moving. That velocity is given by V is equal to m into E, where m is nothing but mobility of ions and E is nothing but electric field. The applications of electrophoresis are much wider. It is widely used in medical fields, and in biology it is used in DNA sequencing. That type of electrophoresis is nothing but gel electrophoresis, which uses agarose gel, and in biology it is used to, in medicinal field it is used to separate antibodies. So there are plenty of application. In food industries also electrophoresis plays a major role. So there are plenty of applications of electrophoresis. Here is the example of electrophoresis in two asymptotic liquids, right? So here the particle size is A. When we consider the particle size much lesser than lambda d, it can be neglected, and due to the drag force at this condition, due to the viscous drag force and due to the Coulomb force, as we know that whenever the charge is in an electric field, it experiences a force which is nothing but Coulomb force or electric force. So the Coulomb force and electric force, due to the presence of Coulomb force and electric force, the electrophoretic velocity in accordance with Huckel equation is given by this formula, where 2 epsilon naught zeta divided by 3 mu, where that symbol is known as zeta potential. So here I am ending this video lecture. Thank you so much, sir, for your time, consideration and patience.